I hope the screen is visible to all of you. Is it visible?
Yes, ma'am.
Yes.
Okay. Okay, so uh, today we are going to continue our discussion on diodes, and we will see two very important applications of the diodes. These will be the rectifiers and the flippers. So to begin with, let us recall what we were discussing in the previous class. So we said that let me consider a very simple circuit where I will place a diode in series with the resistance R and apply some voltage across this combination. Then we said that because diode is a non-linear device, so the conventional techniques that we have been using in order to calculate the voltages and current across the circuit elements in an electrical circuit will no longer be useful in that case. So then how do I calculate the required value? So for that we saw that there could be two possibilities, either graphically or by using numerical methods. Both of these techniques unfortunately may not be that practical for solving the circuits because they are a bit elaborate and drawing graphs all the time is not possible. So under this situation, in order to find out the solution, what we said that we are going to simplify the description of the diode, and to simplify the description of the diode, we described an ideal diode and said that in this case, when the diode is considered an ideal diode, we are going to ignore any voltage drop that happens in the forward bias region. So that means when the diode is forward biased, I am going to simply substitute that diode with a short circuit. Whereas when the diode is reverse biased, at that time it could have some voltage drop across it that will be negative, but I will not assume that any current is flowing. So that means in case of the reverse biasing of the diode, I will simply replace it with an open circuit. So now we are going to solve the circuits by keeping these assumptions in mind, that whenever the diode is forward biased, we just replace it by short circuit, and when the diode is reverse biased, we just replace it by open circuit. Okay, so this is just the same thing, representation in the form of a diagram. So here you have the forward bias case and here you have the reverse bias case. So with this assumption, we get back to the original circuit from where we started. So we had a diode D which was placed in series with resistance R, and a voltage source of Vs is applied across this circuit. And then it is required to find out V0, where V0 is the output voltage across the resistance R. So let us see what happens in this case. So let me say that Vs is a DC voltage. So if Vs is a DC voltage, this could simply be a battery. So what will happen? If this is simply a battery such that this is the positive terminal and this is the negative terminal, then what will happen? You see that the positive terminal of the voltage source is connected to the positive terminal of the diode. That means in this case, the diode is forward biased diode. And we just said that whenever the diode is forward biased, I'm going to replace it with a short circuit. So next what happens is I'm just going to replace this by a wire or a short circuit. And I want to know the value of output voltage V0, and this is very simple. Now you have only one voltage source, and across the voltage source you have the resistance connected. So all the voltage which is coming through the voltage source is going to drop across this resistance. So in this case, I know that V0 will be equal to Vs. Very simple. Now let us see what happens when the applied voltage is an AC voltage. So earlier when I was introducing the concept of biasing to you, I said that we are considering the DC voltage and not the AC voltage. So it's not that AC voltage cannot be applied to the diode, but as we go through in a few minutes, you will see what happens when you apply the AC voltage. So here you just have to keep in mind कि ऐसा नहीं है कि डायोड के across AC voltage नहीं लगा सकते, you can apply. But what happens after applying the AC voltage, this we are going to see in a while. So once you apply the AC voltage across the diode, let us see. Now you know that whenever the voltage is an AC voltage, you have two cycles. One is the positive half cycle and other is the negative half cycle. So first let us consider the positive half cycle. So in case of positive half cycle, what happens? If this is positive, then you know that this end of the diode is also positive. So the diode becomes forward bias. In the forward bias condition, I'm going to replace this diode as the short circuit, just in the similar way that I did over here. So if the diode is replaced by a short circuit, then I have the same condition that I derived earlier, that is V naught will be equal to Vs. And current is going to flow through in this direction, that is in the direction of the symbol of the diode. Now, next, let us see what happens when you have the negative half cycle of Vs. So if you have negative half cycle of Vs, then what will happen? Here you will have a negative polarity, but here the diode is connected such that this terminal is positive. So in the negative half cycle, this same source which earlier forward biased the diode will try to reverse bias the diode. So in case of the negative half cycle, what will happen is that the diode D will become reverse biased. And when the diode is reverse biased, I know that I replace the diode with open circuit. So earlier I replaced this with a wire, and now I will say that this component does not exist. So the resulting circuit will be like Vs, and here you will have an open circuit, and here you have the resistance R across which I need voltage V naught. So what will happen, because this was earlier in series with the resistance R, and now this is an open circuit over here, so no current is going to flow through this. And if there's no current in this circuit, there will not be any voltage drop across the resistance. So for the negative half cycle of the diode, for the negative half cycle of the input waveform Vs, V naught will be equal to 0. So if I want to summarize, in this case, I will say that V naught will be equal to 0 for Vs less than or equal to 0 volts, and this will be equal to Vs for Vs greater than 0 volts. So this is my summary of working of the diode in this circuit. And if I want to plot, for example, if you say that Vs is some sinusoidal waveform like shown in this figure, then we know that for the positive half cycle, V naught is equal to Vs. So the output waveform is going to imitate the input waveform for the positive half cycle of the input waveform. And for the negative half cycle of the input waveform, V naught will be equal to 0. So that's why in the negative half cycle, I do not have any output. So this is how my output is going to look like this. And the waveform over here that I just obtained, this waveform is known as half wave rectified waveform. This is known as half wave rectified waveform. So here important word is rectified. What do you mean by rectification? So by the process of rectification, what we have done is that we have converted an alternating voltage to a direct coupled voltage. So what was my AC voltage? AC voltage is a voltage that was changing its direction periodically. But when I passed it through the circuit, through this circuit is also known as a half wave rectifier circuit. The circuit is also known as half wave rectifier circuit. So whenever I pass an alternating voltage through a half wave rectifier circuit, the resultant output that I get has no output corresponding to the negative half cycle. So when you have applied a DC voltage, then you forward bias the diode. Whatever voltage that you have applied across at the input is going to appear at the output. But once you apply AC voltage, then for the positive half cycle, the diode is going to conduct. But for the negative half cycle, the diode is not going to conduct. So unless you have any application where this type of output is desired, it is not required to apply the AC voltage. But then other problem is that most of the supplies that you have in our homes is not the DC volt supply, rather it's the AC volt supply. So that means I need to do something in order to prevent this happening. Because if this is happening, what will happen? जो negative half cycle में power होता है, I'm losing out on that power. So I'm using only the power which is there in the positive half cycle, and the power which is stored over here is getting wasted, which I do not want. And it's also not possible for me to all the time apply DC voltage across the circuit. So that means I need to make some more arrangements to this half wave rectifier circuit so that I can utilize the entire power which is stored in the input waveform. So for this, what we are going to do, we are going to convert this half wave rectifier circuit to a full wave rectifier circuit. So let us see how this happens. So in case of full wave rectifier circuit, there are two popular configurations. The first configuration is known as a bridge rectifier circuit. And the second configuration is known as the center tap rectifier circuit. So the output in both the cases is same. There is slight difference in the peak inverse voltage, which we are going to see in a while. So let us first see the bridge rectifier circuit. So in case of bridge rectifier circuit, there are 4 diodes which are connected in the form of a bridge. So here you have diode D1, here you have diode D2, then you have diode D3 and diode D4. And in between these, I have a resistance R, across which I want to see the output voltage V0. So let me say that this is D1 and this is D2, this is D4 and this is D3. And I connect this configuration across the voltage source Vs. So when we have 4 diodes which are connected in this way in the form of a Wheatstone bridge, we call this as the bridge rectifier. So let us see what happens if I apply AC voltage to this. So what happens during the positive half cycle of the input voltage? Can you tell me which diodes will be turned on and which diodes will be turned off?
D1 and D3 on.
Yes. So when you have the positive half cycle, then this diode D1 and this diode D3 will be on. Why? Because here this is positive, here this is positive, here this will be negative. So यहाँ D3 का negative terminal है. So positive connected to positive of the diode or negative connected to the negative of the diode is going to forward bias the diode. So for the positive half cycle, we say that the diode D1 and D3 will be on and the diode D2 and D4 will be off. So if D1 and D3 are on, these can be replaced by wires, and here you will have open circuit because we say that when the diode is off, I simply replace this by an open circuit. So the current is going to flow through the voltage source, through diode D1, through resistance R, then through diode D3, and then back to the source. So this is how my circuit is going to look like. So what will be the value of V0 in that case? So in the circuit, I only have one resistance. The current is going to flow from here to here, through here, through here, and then through here. So only one resistance in the circuit and current is flowing again in this direction. So I will have V0 is equal to Vs and say Vs is equal to A sine omega t. So for the positive half cycle, the output is going to imitate the input. Then let us see what happens for the negative half cycle. So if you have the negative half cycle, then you will have negative over here and you have positive over here. If this is negative, then this is going to forward bias this diode because this diode has negative terminal attached to this point. Similarly, over here you have positive. So D4 will be forward biased because the positive terminal of D4 is connecting to this positive end of the voltage source. So in the negative half cycle, you will have D2 and D4 as on. These will be on, and D3 and D1 will be off. So under this condition, the current is going to flow this way. So you will have the current flowing from here to here through this diode, again through the resistance, through this diode, and then back to the voltage source. So in this case, if I want to find out the value of V0, then V0 will be equal to, this will be equal to again Vs, because there is only one resistance in the circuit and the direction is also this way, but we should remember that this is negative half cycle, so this will be equal to minus A sine omega t. So one thing that I gained over here by the use of bridge rectifier compared to half wave rectifier is that I'm having some output both for the positive half cycle also as well as for the negative half cycle also. So if I want to plot this voltage, then say if this is my input voltage Vi equal to some A sine omega t, then corresponding to this input waveform, I will have some output waveform which is going to look like this. So for the positive half cycle, I will imitate the input, and for the negative half cycle, the output will be opposite of the input. So the full wave rectified waveform is going to look like this. This is my Vi and this is my V0. Okay, is this clear? Okay, so here now we define one more term which is known as the peak inverse voltage or PIV. So what is this PIV? PIV is actually the maximum reverse bias voltage that appears across the diode. So in this circuit, let us see what will be the value of PIV. So for example, if I say that I am considering the negative half cycle, so negative half cycle में मैंने कहा कि D2 और D4 जो है, they will be on and D1 and D3 will be off. So if I want to draw the circuit will somewhat look like this. So here I had D2 which is on, here I had D4 which is also on, and instead of D1 and D3 I replaced this with open circuit, and here I have applied my voltage Vs. So let me say that the voltage across this open circuit is V1 and the voltage drop across this open circuit is V3. This is like positive negative, this is like positive negative. So in this case, I want to see what will be the value of V1 or V3 in this case. So if I apply KVL over here, say for example, I'm considering this polarity. So from here I can say that this will be minus Vs plus V1 is equal to 0 because I'm considering the current to flow through this. अगर ये short circuit होता तो current ऐसे जाता from here and then from here. So this is the circuit that I'm considering. So that means minus Vs plus V1 is equal to 0, or V1 would be equal to Vs. That is equal to A sine omega t. Or if I want V1 max, this will simply be equal to A. Similarly, if you want to know what will be the maximum value of V3, then maximum value of V3 is also equal to A. So one thing that we need to observe from here is that whenever I'm using a bridge rectifier circuit, at that time the peak inverse voltage which is the maximum voltage that appears across a reverse bias voltage, is equal to A, where A is the magnitude or amplitude of the sinusoidal waveform applied at the input. Now we are going to see the second configuration, that is the center tap rectifier. In case of center tap rectifier, the circuit looks like this. So you have two voltage sources and two diodes. Let us say this is Vs, this is also Vs. Here you have diode D1. Here you have diode D2. This is tapped in between and grounded over here. And from here I have the resistance R connected in this way. And I'm taking the output voltage over here as V0. So let me call this as D1 and this as D2. So again in this configuration, this is my center tap configuration. So again in this configuration, if I have positive half cycle of the input voltage, then what will happen? Because the positive terminal of D2 is connected to the positive over here, that means D1 will be forward biased. So I can replace this by the short circuit. What about D2? Because here the connection is such that the negative terminal of Vs is connected to the positive terminal of D2. So in this case, D2 will be reverse biased. So this will be open circuit. So in the positive half cycle, the circuit is like this voltage source Vs, this diode D1, and then from here to voltage V0 and the ground. So this is my entire circuit from V through the diode, through the resistance and to the ground. So in this case, again, you have only one resistance in the circuit and one voltage source. So all the voltage that is being applied by this input voltage source is going to appear across this resistance, or you can say that V0 will be equal to Vs. This is equal to A sin omega t. Then what happens when you have the negative half cycle of the input? The functions of D1 and D2 get reversed. So now I have D1 which is reverse biased. So I'm going to open that, and D2 will be forward biased. So I'm going to short this. So now the circuit will be through voltage source Vs, that is a lower voltage source, through diode D2, then through resistance R, and then ground. So what will happen in case of output voltage now? So V0 will be equal to minus Vs, because the polarity over here is reversed, because the positive terminal is connected to the ground over here. So we will have V0 is equal to minus Vs. So that means the output is going to be the same that we saw in case of a bridge rectifier circuit. So if this is my input waveform, the corresponding output waveform will be the same for the positive half cycle and the inverse for the negative half cycle. So this is how my output is going to look like, and this is a full wave rectified waveform. Now let us see what is the peak inverse voltage in this case, because this is where the difference lies when you compare the bridge circuit and the center tap configuration. So what happens? What happens if I want to calculate PIV? So in this same case, say for the negative half cycle, this diode D1 is open. So here you will have open circuit, and this diode D2 is short. So this is short circuit. So let me say that this has voltage V1. So in this loop, starting with this voltage source, this voltage source, this voltage V1, in this loop, not including this resistance, if I apply KVL over here in this loop, then this will be minus Vs plus V1 will be equal to 0. That means V1 will be equal to 2 Vs, or that's equal to 2A sin omega t. So if I want to know the value of V1 max, then this will be equal to 2A. So you can verify this by keeping this diode on and this diode off, or by considering the positive half cycle. Anyhow you do, you will get the value of PIV as 2A. So if you compare the center tap configuration with the bridge configuration, we say that the output remains the same, but in this case, PIV is more compared to the bridge rectifier. So इससे क्या difference पड़ेगा? What will be the difference? The difference is that if I'm using a center tap configuration, then I have to choose VS more carefully. Because if I choose some value of Vs in the reverse bias case, twice of the maximum value of Vs is going to appear across this diode. And if this PIV exceeds the breakdown voltage of this diode, if this PIV is going to exceed the breakdown voltage, then what happens? The diode may go into breakdown region, causing very large current to flow through the circuit, which may not be desired, and it may cause damage of other components which are connected to the circuit. So whenever I'm using a center tap configuration, I need to be more careful while choosing the value of Vs compared to that what I do for the bridge circuit. Is this fine? Any doubts?
Ma'am, here there is no energy loss.
Where?
Like in half wave rectifier, half of the energy was lost.
Yeah, in this case, we do not have energy loss because we are making use of this negative half cycle also.
Okay, ma'am.
Okay, so diode is an element that you can remember as the element which supports only unidirectional flow of current. So whenever you provide alternating kind of waveform, it is always going to convert it to a direct coupled. So this is direct coupled, although it does not look straight because there are ripples in it. This is the difference, but this is not alternating. ये जो ripples आ रहे हैं, these are not alternating because the direction is not reversed. Okay, in that sense, you can say that we are making complete use of the power stored in the positive half cycle as well as in the negative half cycle. Of course, because there is a resistance connected across the circuit, if you talk ये resistance के across तो कुछ energy dissipation होगा, तो हाँ वो तो होगा, वो तो definitely होगा because resistor है. लेकिन if you talk in terms of how much power of the input we are able to utilize with respect to the half wave rectifier, then we are utilizing 100% of what is given to the input. ठीक है?
Okay, ma'am.
Okay. So this was all for the rectifiers. There are two configurations, the half wave rectifier and the full wave rectifier. Next, we start with another popular application of diode, and these are the clippers. So what are clippers? Clippers are basically the circuits that is used to change the shape. Okay, sorry about this line. So these are used to change the shape of the input wave by clipping or removing a portion of the clipper. This is used to change the shape of the input waveform by either clipping or removing a portion of the waveform. So by removing a portion of the waveform, it may impact the rest of the waveform also. It may not impact the rest of the waveform also. So in this case, you will see that below a specified voltage level, we might remove that part of the waveform. Or above a specified voltage level, we can remove that particular part of the waveform without changing the shape of rest of the wave. So this process of reshaping the waveform comes under the application of clipping, and this is possible by the use of the diodes. So typically what type of questions that you will see, first of all, the concepts will remain the same. जो अभी तक हमने concepts पढ़े हैं, the same concepts we are going to apply over here. There's nothing new in the concept, only we need to see that in case of clippers, how we have to apply the concepts. So the questions that you will see over here mostly will consist of an input waveform and a clipping circuit. And we need to analyze the clipping circuit to see that given this waveform, what will be the waveform at the output. कौन सा part clip हो रहा है, किस voltage level के ऊपर clip हो रहा है. These are two important points that if you can determine correctly, you will always get these type of questions as correct. So let us start with this simple case. Okay, before we start, there are three things that I want you to keep in mind while we are analyzing the clipping circuits. The first point is always observe where the output voltage is taken. So in general, the output voltage, at least at your level, it will be a simple question. So generally the output voltage is taken across this resistance, but sometimes you can have the output voltage taken across the combination of elements also. So in that case, we need to be more careful while analyzing. So first rule is, although this you may take for granted after solving maybe 5 or 10 questions, but at least for the first few questions, always mark where the output voltage is being taken. This is the first point. The second point is that mostly in these type of circuits, what you will have more than one voltage source. So once you have more than one voltage source, we need to see what source is having what impact on the diode. So sometimes one of the voltage source may try to forward bias the diode, another voltage source may try to reverse bias the diode. So what is the net impact on the diode? Which voltage source is dominating? This finding out that which voltage source is dominating is our second step. And the third step will be to identify the transition voltage. Identify the transition voltage. So what is the transition voltage? So you may have the situations where below some specified voltage level, the diode was off, but above that specified voltage level, the diode will be on. So that voltage, that particular voltage from where the diode is either going from on to off or from off to on is what I'm calling as the transition voltage. So if you get these points, particularly these 2 points correctly, then you can have the correct output waveform also. So with these 3 points in mind, let us start analyzing the clipping circuits. So here we have the first example. This is the example of a series clipper. Why it's called a series clipper? Because here the diode is in series with the applied input voltage. Later on, we are going to see the cases where this diode could be placed over here in the parallel branch. So those are known as the parallel clippers. So let's start with the series clipper. Okay, so here you have 2 voltage sources. One is the voltage source Vi. So this we are going to typically now say that Vi will be an AC voltage source. क्योंकि अगर DC लगाना होगा तो there will be a separate battery placed alongside. So in general, if nothing is mentioned, then we need to assume that this small Vi is the AC voltage source. So there are 2 voltage sources. One is AC, one is small Vi, which is going to be the AC voltage, and other is the capital V, which is a battery, typically a DC voltage source. So now given this, the first thing that we mark over here is that V0 is taken across resistance R. Okay, this is fine. The second thing is, when there are 2 voltage sources, we need to see which one is impacting the diode in which way. So, okay, we now clarify or observe over here that there are 2 voltage sources. One is the small Vi and then other is the capital V. What effect small Vi will have on the diode? So we know that this is going to be an AC voltage. So when you have the positive half cycle, then what happens? Because the diode is connected in this way, the positive terminal is facing towards this voltage source small Vi. So if you have a positive voltage source, then this end is positive and this end is also positive. So if Vi is positive, that's in the first half cycle, it will try to forward bias the diode. Whereas what will happen if Vi is negative? If Vi is negative, then here you have negative, here also you have, okay, here you have negative, here you have positive. So this is going to reverse bias the diode. So this is the effect of small Vi. What about the effect of capital V? So capital V will not change its polarity. So this is fixed. So here you have the negative terminal of this battery connected to the positive of the diode. That means under the effect of capital V, the diode is always going to be reverse biased. ठीक है? So now let us see when the diode is going to switch on. When the diode is going to switch on, the condition is that for the diode to switch on at this point, let me call this point as point A. So the voltage at point A should be greater than or equal to 0 in order for this diode to be switched on. So if I have two voltage sources connected in this way, what will be the value of voltage VA? This will be equal to VI minus capital V. That means VI minus capital V must be greater than equal to 0, or VI must be greater than or equal to V. So as long as VI is greater than equal to V, this diode is going to be on. If VI is less than V, then the diode is going to be off. So we did the third step. So we identified that my transition voltage in this case is capital V. Now, in order to draw the output waveform, what I need to see is, I need to see if the diode is on, how much voltage is going to appear at the output. तो यहाँ पे एक और fourth step add कर लो, that is to find out what will be the value of V0 when the diode is on and what will be the value of V0 when the diode is off. So the diode is going to be on for all the values of input voltage greater than capital V, and in that case, what is that you are going to obtain at the output? So if you apply KVL over here in this loop, this will be minus VI plus V plus VD, which is the voltage drop across the diode, plus V0, this is equal to 0. And VD is also equal to 0 because we are assuming the ideal diode, we do not have any voltage drop across it. So that means V0 that will appear across this resistance, this will be equal to VI minus of capital V. So this is the output when the diode is on. And what about when the diode is off? If this diode is off, here you have an open circuit. If this is open circuit, no current flows through this circuit, no current flows through the resistance, so V0 will be equal to 0. So if I want to draw the output waveform corresponding to this input waveform, this is going to look like this. So here I had my input waveform, and what was my analysis saying? My analysis was saying that whenever Vi is greater than or equal to V, at that time V0 will be equal to Vi minus V, and when Vi is less than V, that time V0 will be equal to 0. So if say capital V is this line, so for all the voltages which are below V, that means in this region that I am marking over here, and in this region over here. So all this region, this lies below capital V. So for all this input, I'm not going to have any output. I'm going to have output only for this small region. और इस small region में भी कितना output मिलेगा? It will not be Vm. It will actually be Vm minus V. So that is how I denote Vm minus V over here in the output waveform. And the transition voltage is corresponding to these points where I will say that Vi is equal to V. So from here over this point, the diode will change the state from being off to on, and at this transition point, the diode is going to change the state from being on to off. Is this clear?
And what was the transition voltage?
This is V. अभी हमने कोई value इसकी नहीं ली है, so you can say that this is simply V, and V is the voltage that this battery is carrying.
Okay, so V is the transition voltage.
Yes.
Okay, ma'am.
ठीक है? So next what we do is, let us try to reverse the polarity. So the combinations can revolve around this. in the question you may have different polarity of this applied battery, or you can change the direction of this diode. ऐसे करके अलग अलग configurations बनते जाएंगे, and corresponding to different configurations you will have different values of the output waveform. So for example, here I am considering the case where the direction of the battery is reversed. So if you look here, यहाँ पे negative terminal was towards the positive of the diode, but here what I have considered, now I am reversing the polarity. I am taking the positive of this towards the positive of the diode. So because of this battery, DC voltage, the diode D is always going to be forward biased. Then let us see what is the effect of the AC voltage. तो AC में क्या होगा, जब positive half cycle आएगा तो for the positive half cycle the diode will be forward biased, and for the negative half cycle the diode will be reverse biased. So that means when there is positive half cycle, then direct current की वजह से तो पहले ही forward biased था. अगर AC भी positive होगा, then diode will definitely be forward biased. But if the AC is negative, then the diode could be reverse biased or it could be forward biased also, depending upon which is dominating. VI is dominating or capital V will be dominating. Or this means that in this region we need to find the transition voltage जहां पे diode off से on या on से off होगा. Okay, so let us see how it will be. So first point we mark over here that okay, V0 is taken across this resistance R. Then the second thing is we have analyzed because of two voltage sources when the diode will be on and when the diode will be off. So I say that the diode is going to be on. The diode is going to be on when you have the positive half cycle. And what will be the output voltage when the diode is on? So if the diode is on, this will be replaced by a short circuit. So can you tell me how much will be the value of V0? So if I apply KVL over here when the diode is on, this will be like minus of VI minus capital V plus VD plus V0 is equal to 0. This VD is going to go away, or you can say that V0 will be equal to VI plus capital V. So when the diode is on, that time the output voltage that will appear across the diode will be how much? This will be VI plus V. Earlier case it was VI minus V. So these parameters are going to change as you change the polarity of either the applied DC voltage or you change the polarity of the diode. So this is one thing. Now the next thing is what happens when the diode is off. So that means in the reverse bias, I mean in the negative half cycle of the input voltage. So the condition I know, if I say that this point is A, the condition I know that for the diode to be switched on, the voltage at point A should be greater than or equal to 0. So if voltage at A should be greater than equal to 0, what will be the voltage appearing across at point A in this configuration? This is equal to minus of VI minus V. This should be greater than or equal to 0, or from here you can say that VI must be greater than or equal to minus V for the diode to be switched on. So whenever VI is greater than or equal to minus V, at that time the diode will be switched on and the output will be VI plus capital V. And then obviously if for this condition the diode is switched on, for VI less than minus V, the diode will be switched off. And if the diode is switched off, this will be open circuit. Everything is in series. Agar ye open circuit ho jayega, to no current is going to flow through the circuit, and therefore V0 will be equal to 0. So the point over here is, jab positive half cycle hai VI ka, that time the diode is definitely forward biased, giving me this output voltage. But for the negative half cycle of this VI, it is not that for the entire negative half cycle the diode is going to be reverse biased. पूरे negative half cycle के लिए diode reverse bias नहीं है. The diode will be reverse biased only when VI goes below minus V. So for other values of Vi in negative half cycle which are greater than minus V, the diode is still going to function. So this is a small difference with respect to the case that we saw earlier. So now we have the output voltages also under the two conditions. We have the transition voltage also. So let's see how we can draw the plot. So this is how the plot is going to look like. So here you have a sinusoidal voltage of 20 volts peak as the input, and the value of V was equal to -5. So we just saw that my diode is going to be on for Vi greater than or equal to -V. That means for Vi greater than equal to -5 ही मुझे output मिलेगा. So here if I say that this is my line of -5 and all the voltages below this are less, so I'm not going to get any output corresponding to this region. So that means in this region I'm not going to get any output. And what about the other region? Other regions are above -5 volts, so I will get the output, but what will be the output? The output will be equal to Vi plus V, that means Vi plus 5. So this entire waveform jo bachi hai, this is going to shift upwards by +5 volts. So in this figure, what we did is, ye jo niche remaining waveform bachi hai, this has just moved upward by 5 volts. So now the peak is not 20, but it is 20 plus 5, 25. And in this region corresponding to this shaded part, you will not have any output. Thoda sa output yahan pe milega while the curve is tapering down. So you might have a little output over here in this red region and some output over here in this red region. The rest of it, you will have no output. Is this clear?
Ma'am, that tapering region, why is that?
Yeah.
Ma'am, that tapering region, why do we have forward bias there?
We have tapering region में forward bias इसलिए है because here Vi is greater than -5, right?
Okay.
This is what we concluded over here. So it is not that कि Vi जब negative half cycle है तो पूरे negative half cycle के लिए output 0 नहीं है. The output is 0 or the diode is reverse biased only when Vi is going below -V. So if say Vi is equal to -3, so -3 is actually negative half cycle of Vi, but in this negative value also the diode is forward biased because of this additional 5 volts. Okay. Okay, so then we see one more example. This is the case of a parallel clipper. Parallel clipper, why? Because here the diode is added in a parallel branch to the input voltage source, but nevertheless it's not going to make any difference to the logic that we are using to analyze the circuits. So what happens for a given value of Vs, we need to find out the output voltage, where output voltage V0 is taken across this resistance. Okay, so what are the two voltage sources that are present over here that are going to impact the working of the diode? The first voltage source is this voltage source Vs, and another voltage source is this battery of 3 volts which supplied over here. So अभी Vs की कोई value इन्होंने नहीं दी है. So in case Vs की कोई value नहीं देंगे, तो let us say that I am assuming that the diode D is forward biased. So you see over here, if you see the battery, the positive of the battery is connected to the negative of the diode. So because of the DC source, the diode D is always going to be reverse biased. But because of the voltage source Vs, it depends. In the positive half cycle, it is going to try to forward bias the diode. In the reverse half cycle or in the negative half cycle, it will reverse bias the diode. So ultimately, diode कैसे function करेगा will depend upon which one is dominating, if Vs is dominating or if this is dominating. So for this, let me say that abhi I don't know the value of Vs, so I cannot compare the values कि यहाँ 3 है, यहाँ 6 है, तो कौन सा बड़ा है, ये अभी direct को नहीं कर सकते because the value of Vs is not yet known. So what I do is I start with an assumption. I assume that D is on. If D is on, that means Vs is dominating. So if Vs is dominating and D is on, this will be replaced by a short circuit as shown over here. So in this case, let us write the expression for current I1, I and I2. So what will be I1? I1 is the current flowing through this 1 kilo ohm resistance. So if I want to write the expression of I1 by Ohm's law, this will be equal to Vs minus 3 divided by 1000. And what will be the value of I2? I2 will be equal to 3 divided by 2000. So this is equal to 1.5 milliamperes. Then what will be the current flowing through the diode I? The current flowing through the diode I, this we can find out by applying KCL at this point. So the net input current should be equal to the output current over here. So I1 will be equal to I plus I2, or I can say that I will be equal to I1 minus I2. That means this I will be equal to Vs minus 3 divided by 1000 minus 3 divided by 2000. So this is the amount of current which is flowing, which is supposed to flow through the diode. And then since we have assumed that the diode is on, if the diode is on, that means this current should be greater than 0. So if this current is greater than 0, then from here you can say that Vs minus 3 by 1000 should be greater than 3 by 2000, or Vs must be greater than 4.5 volts. Okay, that means for this diode to be on, Vs should be greater than 4.5 volts. And if Vs is greater than 4.5 volts and the diode is on, what will be the value of voltage that you will obtain over here? What will be the value of V0? Now this branch will come directly in parallel with this branch where you have the 3 volt source. So under this condition, V0 will be equal to, simply by voltage division rule, this will be equal to 2 by 3. No, not 2 by 3. This is actually in parallel with this. So V0 will be equal to 3 volts. So the conclusion over here is, we have found the value of transition voltage, that is for Vs greater than 4.5 volts, the diode D will be on, and when the diode D is on, the output voltage will be 3 volts. Then what happens if Vs is less than or equal to 4.5 volts? In that case, the diode will be off. So if the diode will be off, this short circuit will be replaced by open circuit. And in that case, what will be the value of V0? So now no current is going to flow through in this branch. So I will be equal to 0. So you have only two resistances, 1 and 2, which are in series placed across this voltage source Vs. So V0 will be equal to, by voltage division, 2 by 3 multiplied by Vs. So the conclusion is that if the diode is on, that means for Vs greater than 4.5 volts, the output V0 is equal to 3 volts. And when the diode is off, this is the condition when Vs is less than equal to 4.5 volts, that time V0 will be equal to 2 by 3 times of the applied voltage Vs. So here in the plot, you are given an input voltage waveform of 6 sine omega t. So corresponding to this, we need to plot the output waveform. So whenever the input waveform is greater than 4.5, that means maybe somewhere over here around this region. you will have the output only as 3 volts. So this is my 3 volts in the output, and this point corresponds to the region where the input waveform Vs is greater than 4.5 volts. And for the rest of the input, what will be the value? This will be equal to 2 by 3 times of 6 sine omega t. So this is 2 and 2 gets multiplied. This will be equal to 4 sine omega t. So for other region, that is where Vs is less than equal to 4.5 volts, you will have a sinusoid which will have its peak at plus minus 4. Of course, minus 4 वाला peak है, plus 4 वाला peak नहीं आएगा, because that is going to get clipped, and minus 3 is what you are going to get in the positive region, and in the negative region you will have a sinusoid which will have its peak at minus 4. Is this clear? So that means in a way you have clipped this portion of the waveform. You have clipped this portion of the waveform. You can have many more different configurations, again by changing the polarity of the diode, by changing the polarity of this voltage source. एक और configuration होता है जिसमें you can have another diode over here in parallel with some battery. So in that case, you will clip both the top portion also as well as the bottom portion also. So this way different configurations are possible, but the logic remains the same. So first of all, very important thing, you need to identify what are the voltage sources that are making an impact on the diode. Then given that voltage source, what will be the transition voltage from where the diode will go from on to off and from off to on. And then when the diode is on, what will be the value of output voltage, and when the diode is off, what will be the value of output voltage, and then corresponding to the input voltage, you can plot the output voltage waveform. Is this clear?
Ma'am, when the voltage is greater than 4.5, in that case, we have Vs which is varying, but still the V0 is not varying. Why is that?
Yeah, because when Vs is greater than 4.5, then V0 is fixed. 0.3 volts आया ना, क्योंकि in the previous slide we saw that when Vs is greater than 4.5, the diode is switched on. When this is switched on, this is behaving as a short circuit. So what happens? This 2 kilo ohm resistance comes in parallel with this 3 volt battery. So इसका जो voltage source है, that is going to appear over here. That's why this is not varying as the input is varying.
But at that time, is not Vs like contributing any voltage?
No, because ये parallel combination हो गया ना, ये सीधे parallel combination हो गया.
Okay.
So rectifier portion is still easy, लेकिन clippers में बहुत confusion होता है. So you try to solve more questions. Book में दिए हुए examples में भी हैं, and in the unsolved also they are given, but obviously because you have the solution, so I would like you to emphasize more on the clippers, क्योंकि यहाँ पे confusion के chances बहुत ज़्यादा होते हैं. So try different configurations, diode की polarity change करके, voltage battery की polarity change करके, waveform change करके. So it's not that this is valid only for sinusoidal. This could be any alternating voltage. It could be like this way also. It could be a square wave also. The concepts will remain the same. Only you need to see that which portion will get clipped off. So if there are no more doubts, I'll close for today. And tomorrow there is also a class, because tomorrow it's Wednesday's timetable. So tomorrow we'll start with the Zener diode. And tomorrow and day after, I think we'll finish the Zener diode, and next week we'll start with the transistors.
Ma'am, do you have any quiz lined up?
Probably next week. I don't know. There is no announcement, but I'm just telling out of my own intuition. क्योंकि 5 quiz होने थे ना, 3 quiz हो गए, 2 more quizzes are supposed to be there. And how many weeks are left?
The companies are starting from 19th.
Compres are starting from 19th. Yeah, so if they are starting from 19th, then we actually have 2 more weeks. So let's see. Actually, बीच में ऐसा भी discussion हो रहा था कि we can have maybe we can limit the number of quizzes to 4 and take best of 2 out of those 4. I don't know. It depends upon the IC. अगर next week quiz होगा तो I'll let you know by Friday or in any case latest by Monday. So clear answer is that I don't know अभी तक.
Okay,
I'll let you know. Any other issue?
Ma'am, if there are 5 quizzes, then 2 will be buffer, right?
Yeah, initially it was planned that if there are 5, we'll take best 3 of them. But it depends actually. कुछ instructors कह रहे थे कि ज़्यादा quiz ले लो जिससे ज़्यादा buffer हो, but I don't think that ज़्यादा quiz लेने का time है. So it will depend, things may change.
Okay, ma'am. Ma'am, I had one doubt in the center tab configuration.
Yeah.